Hello, my name is Raphael Radna. I am a PhD candidate in composition at the University of California, Santa Barbara. This presentation, and the paper on which it is based, introduces Space Control, a forthcoming software application for sound spatialization. I am developing this software in collaboration with João Pedro Oliveira. Space Control aims to provide an intuitive means of creating spatial gestures for studio-based electronic music composition. It allows for the simultaneous spatialization and mixture of up to 256 individual mono sound files. The program has been designed with simplicity and efficiency in mind. Since it requires only minimal technical configuration, we consider it to be a practical yet powerful solution for composers who are not specialists in either spatial audio or computer programming. We hope that anyone will be able to open the program for the first time, quickly learn the basics, and produce results almost immediately. Towards this aim, the program provides an easy-to-use graphical interface which is divided in three main parts. The timeline displays a waveform overview of a sound file, above which the user places anchor points to define the start and end times of spatial movements. The space interface presents a circular, two-dimensional representation of the sound field, in which corresponding points appear and are placed to define the start and end locations of spatial movements. Finally, the mixer allows the user to balance the individual sound files comprising the entire spatial image, and provides tools to assist the multi-track composition process both aurally and visually. In Space Control, each sound spatial path is conceptualized as a sequence of linear movements. As there is no limit to the number of segments used in a single path, each one can be arbitrarily complex. The user can also define the speaker arrangement used by the program. Common standards such as an octaphonic ring may be easily selected. I will now give a demonstration of the software to give a sense of how quick and easy it is to use. Here we have the application window. At the bottom we see the timeline. On the left is the space interface, and on the right is the mixer. To begin, I'll click the Open button on the first channel strip. This prompts a dialog window for choosing a sound file. Once a file is selected, its waveform appears in the timeline display. The next step is to create some time points. We do this by clicking along the horizontal line above the waveform between the endpoints. The vertical lines that appear from the anchor points help us to align their placement with features in the waveform. Now you can see that points have appeared in the space interface, one for each that was created in the timeline. The numbers on each of these points correspond with those in the timeline. We can click and drag them to create a spatial path through which the sound will move. Now, when we play the sound file, it will be panned over time according to its position in the spatial field. Timeline point 0 corresponds with space point 0, and so on. Please bear in mind that the program performs multi-channel playback, but the audio has been reduced to stereo for this video. Once we are happy with the spatialization, all that is left to do is render and export. Both of these functions are accessed from the audio menu. First, we render. That'll take just a moment. After rendering, we select Export to save the mix to disk. This again will just take a short while. By default, individual mono stems are saved, one for each output channel. You can see here that our 4 mix files have appeared. However, it is also possible to export a single interleaved file, which contains all the output channels. So that about covers the basic operation of the software. But now let's go ahead and add another sound. I'll open a new file on the next track. Notice that the interface is now switched over to track 2 as well. If we want to view the spatialization that we already did as a reference while working with other files, we can press the Keep button on channel strip 1. Its path is now drawn in the background of the space interface. I'll now go ahead and spatialize the second sound file. We can also apply a custom color if we like for greater contrast. By the way, we can specify the speaker arrangement within the space interface. This is done by clicking on any of the available speaker locations around the edge of the circle. For instance, like so. We can also remove speakers that have been added by clicking on them. For convenience, we can also pick one of the default arrangements that are available from the layout menu. In this case, let's switch to an octaphonic setup. So let's create a spatial path for our second file. Also, the mixer is used to balance the channels. The mute, solo, and gain controls operate as you would expect, but each channel also features a volume automation graph, which is superimposed on the waveform. You can use it to apply an amplitude envelope to a sound. For example, now let's hear our new mix. All of the mix settings and the amplitude envelope are applied in real time while monitoring, but are also used when we save the mix to disk. I hope that the demo impressed upon you the speed and ease of using this software. At the same time, Space Control offers powerful and precise means of rendering spatial images. I will now further contextualize the project by discussing its motivation and design philosophy. There are several motivations behind the creation of Space Control. In contrast to available spatialization tools, we aim to offer an option that focuses exclusively on an intuitive approach, in which the composer specifies spatial movement directly. To minimize distractions from this goal, the configuration and operation of the program have intentionally been kept very simple. We have also carefully circumscribed the feature set to streamline development and to avoid diluting the purpose of the application. As an example, communication with external applications or devices, such as by OSC, has not been implemented. Space Control can be used as a general-purpose spatializer, as it supports custom speaker layouts and is therefore not limited to a specific sound system. Since it exports standard wave files, the mixes that it creates can be easily transferred to different performance environments or processed further in additional software. Another core design tenet of Space Control is to offer a non-modular standalone application. By contrast, a number of spatialization tools are available that intend for the user to design and construct their own systems from elemental components. These may require deep technical knowledge of spatial audio, computer programming abilities, or both, as well as lots of time and experimentation to set up. By contrast, space control is ready for use as soon as it starts up, with no special skills or setup required. Anyone who can use a computer can compose spatial music with space control. Finally, and very importantly, the software will be released as freeware. A number of professional-level commercial spatial audio applications are available at high cost. If the goal of space control is to provide access to simple, intuitive, and powerful spatialization, then we view its release as a free download as an important consideration for promoting this mission. I have already explained and demonstrated the graphical interface, so now I will discuss space control's general implementation and audio engine. Space control is developed in Max and relies heavily on its embedded JavaScript capabilities. This facilitates improved program organization and design, streamlined data management, custom interface elements, and faster than real-time audio processing. A central element of the program design is the separation of the interface from the audio processing components. This allows the abstraction and replication of the class representing a single track, which enables the program to scale to a variable number of tracks. In Max terms, this means that the audio rendering functionality is embedded in a polytilde object. For the spatialization method, space control uses an amplitude panning-based algorithm that aims to diffuse a sound using the least number of speakers at any given time. In this scheme, a sound can be reproduced using as few as 1 or as many as 4 speakers. Sounds placed on the circumference of the circle will be spatialized to one speaker or between a pair of adjacent speakers via equal power panning, depending on its location. Sounds located in the interior of the circle are additionally panned between another pair of speakers on the other side of the circle. The radius to the sound's position determines the balance between the two pairs of speakers. To conclude, we hope that this presentation has inspired interest in space control. We expect to release the program in the second half of this year. It will be available on macOS with the possibility of a Windows version. I recommend checking the UCSB Department of Music website periodically for updates in the coming months, as an announcement will be made there when the software is available. Development is ongoing and a number of new features are still planned. These mainly address quality of life upgrades to the interface, such as the ability to save and recall an entire program session or to zoom the timeline horizontally, for example. We also intend to implement the ability to apply transformations to spatial paths for compositional purposes. These will include inversion, retrogradation, and randomization of the spatial points, among other possibilities. In the more distant future, we hope to produce a second version of the software which could run as a plugin in a DAW. The goal of this version would be to integrate this simple and intuitive approach to spatialization more fully into the process of studio composition. As such, it would ideally run directly in the DAW, without the need for communication with an external app such as a rendering server. In this iteration, we would also like to address ambisonics and binaural rendering, and add support for three-dimensional speaker arrays. If you are interested to know more, I refer you to the paper in the conference proceedings as it includes details that could not be included in the talk. Please also feel free to contact me directly. My email address is rradna@ucsb.edu. I thank you very much for your time and attention.